Okay, so welcome back. So now in this video, we're going to use the midpoint rule to estimate this integral. Okay, we're going to use 4 subintervals, and so we're going to figure out what those subintervals are, and then we're going to use the midpoint rule and find the Riemann sum and sum up the areas of those 4 rectangles. And then what we're going to do is compare that to the actual integral and see what the difference is. Okay, so first of all, we need to find delta x, right? So delta x is what? It's b minus a divided by n, right? So this is b minus a over n. And so now a is 0, b is 1. So this is going to be 1 minus 0 over 4, which equals 1/4. So the length of each subinterval is 1/4. Now that tells us that, again, where are we starting? A is 0. So the first subinterval goes from 0 to 1/4. Okay. And then the next interval goes from 1/4 to 1/2. And then 1/2 to 3/4, and then 3/4 to 1. And so we get our 4 subintervals. Now that should always happen, right? So whether it's 6 subintervals or 8 subintervals or 20, we should be able to partition this and start at 0 and end with, or in this case, start with A and end with B. Okay, so this worked out perfectly, okay, and it always should. Okay, now what we're going to do is now our set of right. So this is our partition, right? This is our set of subintervals. Well, not really our partition, but our subintervals. But then our set of midpoints, right? So we're going to find the midpoint of each subinterval. Okay? Well, once we find the midpoint of the first subinterval, we could just add 1/4 to get the next one. Okay? So we don't have to take the midpoint of each one. We can if you want to, but once you find the midpoint, all you have to do is add the width, right? The length of the subinterval to jump to the next midpoint, because these are all regular subintervals. Okay, so the midpoint of this one is going to be the halfway point between these two, which is going to be 1/8. Okay, now all I'm going to do is add 1/4 to get every single other midpoint, or in this case, we're going to add 2/8. Okay, so this would be 1/8, and then this will be what? 3/8. And then the one for this one is going to be 5/8. And, oops, 7/8. Okay? So a little easy trick to understand. Okay? Now that we've got our m sub i's, right? This is our sample, these are our midpoints. So this is M1, M2, M3, M4. Okay, so now all we're going to do is we're going to put it into our midpoint formula, if you will, the Riemann sum. So M4 equals the sum for I equals what? 1 to n of what? F of m sub I times delta x. So now all we're going to do is just plug it in. So what's f of x? Or f of x is x squared. So this is going to be equal to sum from I equals 1 to n of how do I want to do this? M sub I squared times a fourth. Right? And so now all this is going to do is, all I'm going to do is from I equals 1 to n is just plug in these values and square them, just like the function says. So this is going to be 1/8 squared times a fourth plus 3/8 squared times a fourth plus 5/8 squared times a fourth plus 7/8 squared times a fourth. And then of course this is just going to equal 1/4 times 1/8 squared plus 3/8 squared plus 5/8 squared plus 7/8 squared. And what do we get? This is going to be 1/64 plus 9/64 plus 25/64 plus 49/64 times a fourth. Okay, and so what do we get? If we add up all of these, we get 84. Right? 84 over 64. And then if we simplify this, this becomes 21 over 64. Which is not reducible, I don't think. Yep, 21 over 64. Okay. Now that's the answer using the Riemann sum. That's our estimate. Okay. Okay, so now what is the actual? So that's the approximate value of the integral, right? So now what is the exact answer? So I'm going to keep that down there. Now, as we know how to integrate this easily. So this is just going to be 1/3 x to the third from 0 to 1. So this is going to be 1/3 times what? Right, it's just going to be 1 to the third minus 0 to the third. Which equals 1/3. Now if you compare 1/3 to this is very close to a third because 21 cubed, or excuse me, 21 times 3, right? 1/3. So 21 times 3 is 63, which is very close to 64. You know, so the bottom is almost just about 3 times the top. So it's very close to a third. Okay. So if we wanted to find the difference between the two, we would just subtract. So 1/3 minus 21 over 64. And again, if we get common denominators, right, this is going to be 192. Yeah, 192 is also divisible by 3. So this would be 64 over 192 minus 63 over 192. And so we get 1 over, 192, which is an extremely small difference between the exact and the approximation. Now, normally, again, we're going to put error bars, we're going to put absolute value signs behind this just to make sure that we get a positive value. But in this case, it's already positive since we're subtracting a smaller fraction from a larger one. Okay? But normally we would just put absolute value signs in there just in case the error is negative. But we'll talk about that more later. Okay, so this tells us that the midpoint rule gives us a pretty close approximation to the actual value of the integral. Okay. We'll do another one next time. See ya.